For the last 3 years, the entire tech world has agreed on one thing. If you want to win the AI war, you need to buy shovels. And in this gold rush, the only shovel that matters is the NVIDIA H100 GPU. It's the currency of the future. Startups are raising hundreds of millions of dollars just to hoard these chips, and venture capitalists are cheering them on. But while everyone was looking at NVIDIA's stock price, something dangerous was happening in Mountain View. Google wasn't playing the same game. They weren't trying to hoard the most GPUs. Instead, they were executing a silent, decade-long strategy to build a trap. This isn't just about building a faster computer chip. It's about a concept called vertical integration. By controlling the entire stack, from the atoms in the silicon to the cooling pipes in the data center, Google has created a new economic reality. If you are an AI startup renting NVIDIA chips from a cloud provider, you aren't competing with Google. You are essentially paying a tax that Google doesn't have to pay. And when the dust settles, that tax is going to be the reason why a massive percentage of today's hottest AI companies are going to go to zero. But to understand why this crash is inevitable, we have to look at the invisible price tag attached to every single word ChatGPT generates.
Let's break down the economics of a typical AI startup. Let's say you launch a company called Superbot. To train your AI model, you need massive computing power. You can't build your own chips, so you have to rent them. This is where the supply chain eats you alive. It starts with TSMC, the factory in Taiwan that actually manufactures the silicon. They sell the raw chip to NVIDIA. TSMC takes a profit margin. Then, NVIDIA packages that chip, adds their software magic, and sells it to a cloud provider like Amazon AWS or Microsoft Azure. NVIDIA's gross margins recently topped 70%. That is a massive markup. So now, the chip costs nearly double or triple what it costs to make. But wait, you can't buy the chip yet. Amazon or Microsoft buys it. They install it in their servers, they pay for the electricity, the cooling, and the real estate. Then, they rent that computing power to you, the startup. And obviously, Amazon needs to make a profit too. By the time you, the founder of Superbot, actually run your code, you are paying a premium that has been marked up 3 separate times. You are essentially ordering Uber Eats for every single meal. It's convenient, but you are paying for the restaurant, the driver, and the app fees. Now look at Google. Google designs their own AI chips called TPUs, or Tensor Processing Units. They send the designs directly to the factory. Then, they take those chips and put them directly into their own data centers. There is no NVIDIA markup. There is no middleman cloud provider markup. Google pays the cost of goods sold. You pay the market rate. In an industry where computing power can be 80% of your total expenses, this difference is lethal. It's the difference between cooking dinner at home for $5 and ordering the same meal for $40. But price is only half the equation. You might think, well, maybe NVIDIA chips are just so much better that it's worth the extra cost. And for a long time, that was true. But that brings us to the hardware war that has completely shifted the battlefield.
To understand why Google's hardware is such a threat, you have to understand the difference between a GPU and a TPU. An NVIDIA GPU is like a Swiss Army knife. It was originally designed to render video games, Call of Duty, Minecraft, Fortnite. Over time, it evolved to mine crypto and train AI. It is incredibly powerful, but it carries a lot of legacy baggage. It has silicon dedicated to doing things that AI doesn't need. A Google TPU is an ASIC, an application-specific integrated circuit. It is a scalpel. It does one thing: matrix multiplication. This is the math that powers deep learning. Because it sheds all that gaming baggage, TPUs are smaller, denser, and more energy efficient. But the secret weapon isn't the chip itself. It's how they connect. If you are a startup building a cluster of NVIDIA GPUs, you usually have to use expensive cabling to get them to talk to each other. It's complicated, and often the chips spend time waiting for data to arrive. Google took a different approach. They built what they call the Interchip Interconnect, or ICI. Think of it like a superhighway built directly into the silicon. This allows thousands of TPUs to talk to each other with near zero delay. When Google connects 4,000 TPUs together, they don't act like 4,000 separate computers. They act like one single, massive AI hypercomputer. Recent benchmarks on Google's new TPU v5p show that while an NVIDIA H100 might have a higher theoretical top speed, the TPU system is often more efficient per dollar spent. And in business, efficiency per dollar is the only metric that matters. So Google has cheaper chips and a more efficient network. That sounds bad for startups, but it gets worse. Because even if a startup wanted to switch to this efficient hardware, they usually can't. They are locked inside a software prison they built for themselves.
If you walk into any AI startup in San Francisco today and look at their code, you will almost certainly see one framework: PyTorch. PyTorch is the standard. It's flexible, it's community-driven, and it runs beautifully on NVIDIA chips. It's the default choice. And because it's the default, the entire open-source ecosystem is built around it. Google, however, plays a different game. They push a framework called JAX, combined with a compiler called XLA. Now, without getting too technical, here is the difference. PyTorch is like driving a car with a GPS that gives you turn-by-turn directions as you go. It's easy to change your route mid-drive. JAX and XLA are like planning the entire trip down to the millimeter before you even turn on the engine. The XLA compiler looks at the entire AI model and reorganizes the math to fit the physical layout of the TPU chip perfectly. It optimizes the code down to the transistor level. This means Google's code runs faster and uses less energy. But here is the trap. Most startups don't have the engineering talent to write JAX. It's harder to learn, it's more complex. So startups stick to the easy path of PyTorch and NVIDIA. They trade long-term efficiency for short-term speed. As their models get bigger, they hit a wall. Optimizing their code on NVIDIA chips yields diminishing returns, while Google's approach scales linearly. The startups are running a race wearing lead boots, while Google is running in track spikes. But even if you have the best chips and the best software, you still need a place to plug it all in. And this is where Google's strategy moves from the digital world into the physical world of steel and electricity.
We often think of the cloud as this ethereal, magical place, but it's not. It's a warehouse full of hot metal that consumes as much electricity as a small city. Heat is the enemy of AI. The hotter your chips get, the slower they run, and the more likely they are to fail. Most startups rent servers from general-purpose cloud providers. These data centers were built 10 years ago to host websites, databases, and Netflix streams. They weren't designed for the insane heat generated by generative AI. They are retrofitted. Google, because they designed the TPU, also designs the building that holds it. They introduced liquid cooling for their chips years before it became standard in enterprise data centers. They customize their power delivery networks to handle the specific spiky electrical loads of training large language models. It's the difference between buying a suit off the rack at a department store and having a bespoke suit tailored to your exact measurements. When a startup rents capacity, they are paying for the inefficiencies of a one-size-fits-all data center. They are paying for the wasted electricity and the inefficient cooling. Google is paying for a system where every watt of power is optimized. So Google has the cost advantage, the hardware advantage, the software advantage, and the physical infrastructure advantage. You might be wondering, if startups are at such a disadvantage, why are there so many of them right now? The answer lies in a financial ticking time bomb that is about to explode. Right now, the AI industry is living in a bubble of artificial subsidies. If you start an AI company today, Amazon or Microsoft will likely throw $500,000 worth of cloud credits at you. It's free money. It's like a drug dealer giving you the first hit for free. They want to lock you into their ecosystem. So, the startup takes the credits. They spin up thousands of expensive NVIDIA H100 GPUs. They train their model. Everything looks great. Their unit economics look fantastic because their compute cost is effectively zero. But then, the credits run out. Suddenly, the startup has to pay the real bill. And remember that NVIDIA tax we talked about earlier?
Yes.
It hits them all at once. They might be selling access to their AI for pennies, but it costs them dimes to run it. Google doesn't need to play this game as aggressively because their internal costs are inherently lower. They can offer their Gemini API at prices that undercut the open-source hosting costs of their competitors. We are approaching a credits cliff. In the next year or two, thousands of startups are going to wake up to a cloud bill they cannot pay. They will have a working product, great technology, and zero cash left to keep the lights on. This leads us to the grim reality of what the AI landscape will look like in 2026.
Google's ultimate goal isn't just to have the best chatbot. It is to make owning your own AI infrastructure irrational. By widening the cost gap between TPU-native training and GPU-native training, Google is forcing the market to split into two groups. Group 1 is the wrappers. These are startups that give up on training their own massive models. Instead, they just pay Google or OpenAI to use their models and build a nice user interface on top. These companies will survive, but they won't be worth billions. They are just customers. Group 2 is the casualties. These are the startups that try to compete.
They try to train their own foundation models on rented NVIDIA GPUs. They will burn through their venture capital, hit the credits cliff, and realize that their profit margins are negative. Google is positioning the TPU not just as a product, but as a barrier to entry. If you want to compete with Gemini, you need Gemini-level compute. If you can't build your own chips, you have to rent them. If you rent them, you pay the tax. If you pay the tax, you lose on price. It is a strategic checkmate. The AI revolution is often compared to the internet boom of the 90s, but there is a massive difference. In the 90s, everyone bought commodity servers from Intel. The playing field was relatively level. In the AI boom, the infrastructure is proprietary. Google's TPU strategy is a masterclass in long-term thinking. While the rest of the world was obsessed with NVIDIA's stock price and the hype cycle, Google was building a vertical supply chain that fundamentally breaks the economics of the competition. The startups that survive won't necessarily be the ones with the smartest code or the most creative ideas. They will be the ones who understand that in the war for intelligence, the company that owns the silicon owns the future. Thanks for watching. If you want to understand more about the hidden economics of the tech world, make sure to hit that like button and subscribe. See you in the next one.